Now we will go through this example. The voltage phasors of an unbalanced supply is VA is 100 at an angle 30 degrees, VB is 100 at an angle minus 30 degrees, VC is 0 volts. The question is, calculate the symmetrical components of phase A, phase B, phase C voltages. So what you can understand from this, what is asking here, is asking to calculate what is VA0, what is VA1, what is VA2. That's not enough, because these are the symmetrical components of phase A voltages. Now what about the symmetrical components of phase B voltages? The symmetrical components of phase B voltage is nothing but VB0, VB1, VB2. And similarly, the symmetrical components of phase C voltages are nothing but VC0, all are phasors, VC0, VC1 and what? VC2. Now these things we need to calculate here. Suppose he has not mentioned anything, he simply mentioned that calculate the symmetrical components of supply voltages. That is the question. So you need to give the answer for VA0, VA1 and VA2. But if you mention that specifically phase A, phase B, phase C, you need to solve for what? The complete system. So careful. Again I am saying, if the question is given that calculate the symmetrical components of voltages, then you need to calculate only for A phase. Default is for A phase. So VA0, VA1, VA2 if you calculate, that's enough. But if the question is that calculate the symmetrical components of phase B voltage or phase C voltage or phase A voltage, you need to specifically calculate for what? That phase. But whatever may be the question, we can calculate directly for VA0, VA1 and VA2. Once after calculating VA0, VA1 and VA2, and we can calculate VB0, VB1, VB2, VC0, VC1, VC2 simply by using that alpha multiplication. That means maybe alpha is multiplied or alpha square is multiplied. Okay, suppose if it is a zero sequence, means what? VA0, VB0, VC0 are what? Same. So by using simple fundamental principles, we can calculate the remaining two phase information if I calculate A phase information. Okay, now let's see what is VA0 formula. We discussed this in the previous lecture. What is VA0? 1 by 3 times VA plus VB plus what? VC. That's the formula for VA0. Let's substitute this. 1 by 3 times, what is VA? 100 at an angle 30 degrees. 100 at an angle 30 degrees plus 100 at an angle minus 30 degrees plus VC is what? 0. So if I solve this, we get 57.735 at an angle 0 degrees volts. That's about VA0. Clear? Now we need to calculate VA1. See, what is VA1? Let me write the formula first. VA1 equal to 1 by 3 times VA plus alpha VB plus alpha square VC. If I substitute 1 by 3, VA is 100 at an angle 30 degrees. Correct or not? So what about VB? 100 at an angle minus 30. But alpha is what? 1 at an angle 120. Correct or not? So 1 at an angle 120 into 100 at an angle minus 30. Magnitude is 100 only. Phase angle is what? Minus 30 plus 120. Minus 30 plus 120 will plus 90. Anyway, that VC term is 0. You don't need to worry about that. So if I solve this, we get 57.735 at an angle 60 degrees volts. That's about VA1. Now what is VA2? VA2 is what? 1 by 3 times, I am writing the formula, VA plus alpha square VB plus alpha times the VC. VA is what? 100 at an angle 30, VB is 100 at an angle minus 30, VC 0. We need to substitute that. So 1 by 3 times 100 at an angle 30 degrees plus alpha square is 1 at an angle minus 120. So 1 at an angle minus 120 into 100 at an angle minus 30. Magnitude is 100, phase angle is what? Here minus 30 and alpha square means minus 120, so minus 150 degrees. If I solve this, we get 0 volts. It is very simple. Suppose let us say this is 0 degree reference, 30 degrees will be here, 150 degrees means what? From here 150 degrees means you are landed here, correct or not? So minus 150 or 150, whatever it may be. So the point is these two magnitudes are same, 100 at an angle 30, 100 at an angle minus 150. So then these two are what? Cancelled. Okay, clear? So you can also write this is minus 100 at an angle plus 30. Minus means 1 at an angle 180 or 1 at an angle minus 180. So both the way you will get what? Same answer. So finally VA2 value is 0. So we got VA0, we got VA1 and we got VA2, and whose value is what? 0. Clear? Now just check here what else he is asking. So he is asking to calculate what is VA1, what is VB0, VB1, VB2, what is VC0, VC1, VC2. So we are already done VA0. We know that VA0 equal to VB0 equal to what? VC0. So what is that value? 57.735 at an angle 0. So simply 57.735 volts. So next we got VA1 equal to 57.735 at an angle 60 degrees. If that is the case, what is VB1? We know VB1 is alpha square times VA1, correct or not? VB1 alpha square times VA1. If you have any doubt with any formula, you need to draw this phasor. This is positive sequence VA1, VB1 and VC1. So VB1 lags VA1, so that means alpha square times VA1. Okay, so alpha square means 1 at an angle minus 120. Minus 120 plus 60 will be what? Minus 60. So 57.735 at an angle minus 60 degrees. Now what about VC1? Alpha times VA1. Alpha is what? 1 at an angle 120 degrees. Now, so 120 plus 60, 180. So 57.735 at an angle 180. So that is nothing but minus 1. So simply minus 57.735 volts. That's about VC1. Tell me what is VA2? VA2 is 0. If VA2 0, VB2 0, VC2 also 0. Clear? So that's about VA0, VA1, VA2, VB0, VB1, VB2, VC0, VC1 and VC2. Now coming to this example. So in this example, he has mentioned the unbalanced line currents are IR, IY, IB. He is asking to calculate symmetrical components of line currents, but not mention whether it is R or Y or B. So by default is what? R. Okay, but don't confuse, sir. We followed ABC convention, but don't expect that the question will be always asked with ABC convention. It may be asked with what? RYB conventions. But most of the textbooks will follow ABC convention. Okay, but some books will follow RYB convention. Okay, but you don't need to confuse here. A represents R, B represents what? Y, C represents what? B phase. Okay, clear? Now let's see, is asking to calculate in this question what is IR0, what is IR1 and what is IR2. So what is the formula here? So that means according to us IA0, IA1, IA2. Okay, so I am writing the formula directly. IR0 equal to, just similar to voltages, you are replacing V with what? I, everything else same. So I 1 by 3 times IR plus IY plus what? IB. That's about IR0. Now let's substitute 1 by 3 times. IR is what? 10 at an angle minus 90 plus IY simply 10 plus IB 20 at an angle minus 30 degrees. If I solve this, we get 11.286 at an angle minus 36.2 degrees amperes. So that's about IR naught. Now IR1, what is IR1? 1 by 3 times IR plus alpha times IY plus alpha square times IB. So substitute here 1 by 3 times. What is IR value? 10 at an angle minus 90 plus alpha is 1 at an angle plus 120, but IY is just 10 ampere. So finally we get 10 at an angle 120 degrees. 1 at an angle minus 120, minus 120 minus 30, minus 150, magnitude as well as it is, 20 at an angle minus 150. If I solve this, we get 8.34 at an angle minus 153.06 degrees. So that's about IR1. Now similarly we can calculate IR2. So what is the formula for IR2? 1 by 3 times IR plus alpha square times IY plus alpha times IB. Let's substitute here 1 by 3 times. IR is simply 10 at an angle minus 90 degrees. Alpha square 1 at an angle minus 120. So 10 at an angle minus 120 plus alpha 1 at an angle plus 120 and minus 30. So 90 degrees. If I solve this, we get 1.725 at an angle 165 degrees ampere. So that's about IR2. So we are calculated IR0, IR1 and IR2. Now if you want to cross verify whether your answer is correct or not, then you add IR0, IR1 and IR2, you should get what? 10 at an angle minus 90. So what I am saying is, we know that IR equal to what? IR0 plus IR1 plus what? IR2. Correct or not? So what my point is, we got IR0, IR1 and IR2. You add, you should get what? This 10 at an angle minus 90 degrees. Just for cross verification, whether your answer is correct or not. To check that IR0, IR1 and IR2 if you add, you should get 10 at an angle minus 90 degrees. Now we will solve this example. The symmetrical components of line currents are IR0, IR1 and IR2 is given. Calculate what is IR, what is IY and what is IB. Again, so in this question also he has followed RYB convention. Okay, not ABC convention. No problem, it might be RYB convention or ABC convention. Things are same. Okay, only this IR according to us IA, IY according to us IB, I capital B according to us is IC. Everything else remains same. Okay, clear? IR naught means IA naught, IR1 means IA1, IR2 means IA2. Okay. Now let's see here, IR0, IR1 and IR2 is given. I can directly calculate capital IR. What is capital IR? IR0 plus IR1 plus IR2. So if you substitute 0 plus 10 at an angle minus 30 degrees plus 10 at an angle plus 30 degrees. If I add this, we get 17.32 amperes, no phase angle. So indirectly 17.32 at an angle 0 degrees amperes. That's about IR. Now what about IY? IY1 plus IY0 plus IY1 plus IY2. Otherwise what I can write, IY0 is nothing but what? IR0 only, plus what is IY1? Alpha square times IR1, we know this formula already, plus what is IY2? Alpha times IR2. That's the relation. So you substitute IR0 is 0 plus alpha square 1 at an angle minus 120, minus 120 minus 30 minus 150, magnitude as it is 10 at an angle minus 150 degrees plus alpha 120 degrees, 120 plus 30 150, correct or not? So 10 at an angle 150 degrees. So if I solve this, we get minus 17.32 at an angle 0 degrees amperes. Otherwise we can write 17.32 at an angle 180 degrees amperes. Simply this is plus 17.32, this is minus 17.32. Okay, clear? Minus 17.32, this is what? Plus 17.32. Anyway, now what is IB? IB equal to IB naught plus IB1 plus IB2. So how to write this? Just similar to this. IB naught, IR naught are same, correct or not? But what about IB1? Alpha square times IR1. Okay, is that correct? No. Check, sir. If you have any doubt, you have to use this. IR1, IY1, IB1. Tell me. IB1 leads the IR1 by how many degrees? 120 degrees. That means alpha times IR1. Similarly, what is IB2? Again, nothing wrong to write like this so that you will not commit a mistake. RBY sequence, negative sequence. IB2 lags IR2 by 120 degrees. That means IB2 is what? IR2 at an angle minus 120. Correct or not? So that's why alpha square. Alpha square times IR2. Okay. So substitute IR naught is anyway 0. Alpha times IR1. IR1 is 10 at an angle minus 30 and plus 120. 10 at an angle minus 30 is there, plus 120. So minus 30 plus 120, 90 degrees. So directly 10 at an angle 90 degrees. 10 at an angle 90 degrees plus alpha square 1 at an angle minus 120. Minus 120 plus 30 degrees will be minus 90. So 10 at an angle minus 90 degrees. So I can write this is plus J10 minus J10. So which is 0. Clear? So that's about IR, IY and IB. Now how to cross verify? Very simple. Only one thing you need to check. IR not equal to what? 1 by 3 times IR plus IY plus what? IB. Check, sir. IR is what? 17.32. IY minus 17.32. IB 0. So finally IR naught is also 0. We got the same thing. Check. So that's how we can cross verify. Okay. Since we got IR, IY, IB, if you have any doubt that whether your answer is correct or wrong, we can cross verify by using this formula. IR naught equal to 1 by 3 times IR plus IY plus IB. Now we will solve another example. For an unbalanced three-phase system, IA naught is 5 ampere, IC2 is 10 at an angle minus 30, IA 15 at an angle minus 33 degree ampere. Calculate what is IB. Is asking to calculate the IB value. But if I want to solve for IB, we know IB equal to what? IB naught plus IB1 plus IB2. Anyway, IA naught is given, I can calculate IB naught. IC2 is given, I can calculate IB2. But how to calculate IB1? For that I read IA1. Correct or not? So how to calculate IA1? Using this IA expression. Have a look here. What I can write IA here? IA naught plus IA1 plus IA2. Indirectly you know the value of IA that is given. IA naught also you know. IA2 I can calculate using IC2. Then IA1 I can calculate. Okay. Now let's see. What is IA naught? 5 ampere. What is IA2? We need to calculate now. Yeah, for that have a look, sir. Negative sequence I am drawing here. This is IA2. What about this? IC2. What about this? IB2. ACB sequence. Negative sequence. Now let's see. IC2 given us. IC2 we can write. IC2 we can write alpha square times IA2. Now what about IA2? 1 by alpha square times IC2 now. So that means alpha times IC2. Okay, simple. We need to play with these three phasors, nothing else. Otherwise, IA2 leads IC2 by 120. So directly IA2 equal to alpha times IC2. In that way also we can say. Okay, we are just playing with the phasors, nothing else, using alpha parameter. Okay, so I can write IA2. Tell me what is IA2 value now? IC2 value we know 10 at an angle minus 30. Then IA2 is what? 10 at an angle minus 30 into 1 at an angle 120. Magnitude is same, but phase angle 120 minus 30, which is 90 degrees. So we got IA2. We know IA0. We know IA. We can calculate now IA1. Have a look, sir. So from this, IA is 15 at an angle. Anyway, I will write here. IA is 15 at an angle minus 33 degrees. That is equal to IA0, which is 5 ampere, plus IA1 that we need to calculate, plus what about IA2, which is 10 at an angle 90 degrees. So IA1 equal to 15 at an angle minus 33 degrees minus 5 minus 10 at an angle 90 degrees. If I solve this, we get 19.687 at an angle minus 67.35 degrees. So that's about IA1. Now after getting IA1, we can substitute here, we can calculate IB. Now let's check what is IB. IB is IB0 plus IB1 plus IB2. So IB0 is nothing but IA0 plus, okay, what is IB1? For that you can draw positive sequence. IA1, IB1, IC1. Tell me, IB1 is what? Alpha square times IA1. So alpha square times IA1 plus, what about IB2? IB2 from here. IB2 leads the IA2 by 120 degrees. That means alpha times IA2. So IA0, let's substitute 5 ampere directly. Alpha square 1 at an angle minus 120. But what is IA1? IA1 we got 19.687 at an angle minus 67.35. So magnitude is same, 19.687, but phase angle is what now? Minus 120 anyway here, minus 120 minus 67, so minus 187.35 degrees plus alpha 1 at an angle plus 120 times IA2. IA2 we got 10 at an angle 90. 10 at an angle 90 plus 120, 210. Correct or not? 210 can also written as what? Minus 150. 210 can also written as minus 150. So 10 at an angle minus 150 degrees. Otherwise you can put plus 210 also, you will get the same answer. Now you solve this. So if I solve this, we get 23.317 at an angle minus 173.9 degrees amperes. So that's about the final result for IB. Now coming to this example, in this question he has given unbalanced voltages and unbalanced currents, but only given for A phase. It is ABC sequence. VA0 is 2 volts, VA1 is 2 at an angle 30, VA2 is 2 at an angle minus 30 given, and IA0 is 1 at an angle minus 90, IA1 is 1 at an angle minus 60 degrees, IA2 is 1 at an angle minus 120 degree ampere is given. Now first question is what is VA, VB, VC, and second question is IA, IB, IC. Third question is calculate the complex power of phase A, and fourth question is calculate the total complex power. So first we will solve VA, VB, VC. How to solve for VA, VB, VC? It's very simple, sir. So VA equal to directly VA0 plus VA1 plus VA2. Correct or not? So if I substitute that, what I get? VA0 is 2 volts plus 2 at an angle plus 30 plus 2 at an angle minus 30. So if I solve this, we get 5.464 volts. That's about VA. Now what is VB? VB equal to VB naught. Directly I am writing, sir. VB naught is nothing but VA naught plus VB1. VB1 is nothing but what? Alpha square VA1 plus alpha times VA2. So if I substitute, what I get? So VA naught is 2 anyway, plus alpha square VA1, that means minus 120 degrees. So 2 into 2 at an angle 30 and minus 120. So 30 minus 120 minus 90 degrees plus 120 minus 30 plus 90 degrees. Correct or not? So alpha is plus 120, 120 minus 30, 90 degrees. So if I solve this, we get 2 volts, because 2 at an angle minus 90, 2 at an angle plus 90, that will get cancelled. Finally 2 volts only. Now what about VC? VC is, directly I am writing the formula, VA naught plus alpha times VA1 plus alpha square times VA2. Don't confuse. So if I substitute, VA naught is 2 volts anyway, VA1 30 plus 120, 150, 2 at an angle plus 150, then 2 at an angle minus 150. Why? Because minus 30 is there and minus 120. So if I solve this, we get 1.464 minus 1.464 volts. So that's VC. Okay, we got VA, VB and VC. That is the answer for first question. Now what is asking in the second part of the question? In the second part of the question is asking to calculate IA, IB, IC. In a similar manner, we need to calculate IA, IB, IC. But we know that the formula for IA directly, IA naught plus IA1 plus what? IA2. If I substitute, what I get? IA naught is 1 at an angle minus 90, 1 at an angle minus 90 degrees plus IA1 1 at an angle minus 60 degrees plus IA2 just check, 1 at an angle minus 120 degrees. If I solve this, we get 2.732 at an angle minus 90 degrees ampere. So that's a IA value. Now similarly we can calculate IB. So directly I am writing the formula. IB is what? IA naught plus alpha square IA1 plus alpha times IA2. If I substitute, 1 at an angle minus 90 is IA naught plus alpha square times IA1. Alpha square means 1 at an angle minus 120. Minus 120 minus 60 minus 180. So that means 1 at an angle minus 180 plus what about IA2? 1 at an angle minus 120. 1 at an angle minus 120. That multiplied with plus 120, that will be 1 only. Correct or not? 1 at an angle 0. So finally what I get here, simply, so this value is 1 at an angle minus 90, 1 at an angle minus 180, 1 at an angle 0. So this will get cancelled. Finally we get 1 at an angle minus 90 degrees only. So the answer is 1 at an angle minus 90 degrees ampere. Now this is what our IB. Now what is IC now? IC equal to IC naught plus alpha times IA naught plus alpha times IA1 plus alpha square times IA2, sir. Now if I substitute, what I get? IA naught as it is 1 at an angle minus 90 plus, now alpha times IA1. Alpha is 1 at an angle 120. 1 at an angle 120 times IA1. IA1 is what? 1 at an angle minus 60. 120 minus 60 is plus 60. So 1 at an angle plus 60 we can write plus alpha square is 1 at an angle minus 120, and here also 1 at an angle minus 120. So 1 into 1, 1 minus 120 minus 120 minus 240. So 1 at an angle minus 240 can be written as 1 at an angle plus 120. So if I solve this, we get 0.732 at an angle 90 degrees. 0.732 at an angle 90 degrees is IC value. Okay, so we got IA, IB, IC. Clear? That's the second question. And third part of the question is that, third part, calculate the complex power of phase A. So the complex power of phase A only, that means what? We are calculating phase A active power and phase A reactive power. That is what? VA into what? IA conjugate. Clear? So what is VA? VA, just check sir, VA is 5.464. 5.464. IA conjugate. IA is this and conjugate of that 2.732 at an angle 90 degrees. If I do the conjugate, then we get the real part 0. Okay, but imaginary part is that 14.927. 14.9276 VA. That means the active power of phase A is 0, reactive power is what? 14.9276. Now similarly you can calculate SB and SC also. Just check sir, SB. SB is what? PB plus what? J times the QB. So what I get now? VB IB conjugate. So what is VB? VB is 2. And IB conjugate, IB is 1 at an angle minus 90. Conjugate means 1 at an angle plus 90. So simply we get 2 at an angle 90. 2 at an angle 90 means what? We get 0 plus J2 VA. Again, so real part is what? 0. That means active power of phase B is 0. Reactive power of phase B is what? 2 wheres. Now SC. PC plus J times the QC. That is VC into what? IC conjugate. Clear? So what is VC? Minus 1.464, otherwise 1.464 at an angle 180 into IC conjugate means 0.732 at an angle 90 minus 90. So minus 90 plus 180 will be again plus 90. So what I get now? 1.464 into 0.732. So we get 0 plus 1.0716 VA. Clear? That's about SA, SB, SC. If I add this 3, we get what? 3-phase complex power. The total complex power S equal to, I can write like this, SA plus SB plus what? SC. That's what we are trying to say. VIA conjugate plus VBIB conjugate plus VCIC conjugate. Okay. Now if I add, we get 0 plus J18 VA. 0 plus J18 VA. So this is the one method. We are used what? The fundamental formula. VIA conjugate plus VBIB conjugate plus VCIC conjugate. But in terms of symmetrical components, what is S? VA naught, IA naught conjugate. Correct or not? Plus VA1, IA1 conjugate plus VA2, IA2 conjugate. Clear? Now if you substitute and verify, so what is VA naught? 2 and IA naught 1 at an angle minus 90. Correct or not? VA naught, IA naught conjugate. Now 2 into 1 at an angle plus 90 because conjugate. 2 into 1 at an angle plus 90. What I get? 2 at an angle plus 90 means 0 plus J2. So 3 into 0 plus J2. Okay. That is VA naught into IA naught conjugate. What about VA1 into IA1 conjugate? Magnitude is what? 2 and 30 plus 60, 90. So again what? This is also 0 plus J2. And VA to IA2 conjugate also we get 0 plus J2. So what you can understand from here? So 3 into J2, 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 J6. Okay. J6 into 3 will be what? J18. That means 0 plus J18 volt amperes. Both the way we got same answers. Clear? Suppose if the question is only that, what is the complex power of, what is the total complex power? You don't need to do all these things. Since we have a different problems, that's why we are done like this. Directly you can calculate using this. So that means in the GATE exam, he will ask you simply, by giving these values, he will ask to calculate what is the total complex power. Total complex power means Okay, VA naught IA naught conjugate, VA1 IA1 conjugate plus VA2 IA2 conjugate, and overall multiplied with 3. Now we will go through an example on delta connected load. So in this question, the unbalanced line currents are given. He is asking to calculate the sequence components of line currents and phase currents. He has not mentioned whether it is R or Y or B, but by default, what is the meaning of sequence components of line current? IR naught, IR1, IR2. We don't need to calculate IY naught, IY1, IY2, IB naught, IB1, IB2, because he is not asking that. He is simply asking the sequence components of line currents. By default, only for what? The first line, that is nothing but what? R. Clear? And at the same time, he is asking to calculate what is the sequence components of phase current. What is the first phase? IRY. So we need to calculate IRY0, IRY1 and IRY2. So the sequence components of line currents are what? Sequence line currents. IR0, IR1, IR2, and sequence phase currents. IRY0, IRY1, IRY2. Now these things we need to evaluate. Suppose if you want to calculate for line Y and line B, that also possible, because IR0 equal to IY0 equal to IB0. Using positive sequence phasor relations, we can calculate IY1 and IB1. Using negative sequence phasor relations, we can calculate IY2 and IB2. Just similar to that, once I know IRY0, IRY1 and IRY2, we can calculate IYB0, IBR0, because IRY0 equal to IYB0 equal to IBR0. And once I know IRY1, using positive sequence phasor relations, we can calculate IYB1, IBR1. Once I know IRY2, I can calculate IYB2, IBR2. But let's see what is given in the problem. IR value given and IY value given, IB value is not given. Shall I take IB value 0? You cannot take that, because the fundamental relation is, it might be a balanced system or unbalanced system. For a delta connection, the sum of the line currents is always equal to 0. IR plus IY plus IB is always equal to 0. So if it is equal to 0, then IR value is given 50 amperes, 50 at an angle 0 means 50. IY value is given minus 20, because 20 at an angle 180 is nothing but minus 20. So if I substitute here, IR is 50, IY is minus 20, then what is IB? So IB value is what now? Minus 30 ampere. So 50 minus 20 is plus 30. When you send this side, minus 30. So we know IR value 50, IY value minus 20, and IB value is what? Minus 30. So these are unbalanced line currents. So using unbalanced line currents, we can calculate sequence line currents. What is the relation between sequence line currents and unbalanced line currents? IR0, IR1, IR2 are the sequence line currents, which is equal to 1 by 3 times 1 alpha alpha square, 1 alpha square alpha into IR, IY, IB. So what is IR value? 50 ampere. What is IY value? Minus 20 amperes. What is IB value? Minus 30 amperes. Now let's solve this. We get IR0, IR1, IR2. Have a look here. What is IR0 value? 1 by 3 times 1 into 50 plus 1 into minus 20 plus 1 into minus 30. So we get this value 0 ampere. So IR0 is 0. Yes, that is always correct, because fundamentally in case of delta connection, the zero sequence component of line currents is always 0. But what about the zero sequence component of phase current? May exist. Clear? Now let's see what is IR1. IR1 equal to 1 by 3 times 50 plus 1 into 50, 50 plus minus 20 into alpha, minus 20 alpha. Minus 20 alpha means alpha is 1 at an angle 120. So 20 at an angle 120 degrees plus alpha square into minus 30. So that means minus 30 alpha square. Alpha square is 1 at an angle minus 120. If I solve this, we get 25.166 at an angle 6.586 degrees. That is IR1. Now similarly, what is IR2? 1 by 3 times 50 minus. So 1 into 50, 50 minus 20 into alpha square. So minus 20, alpha square is 1 at an angle minus 120 minus 30 alpha, 30 at an angle 120 degrees. If I solve this, we get 25.166 at an angle minus 6.586 degrees. So that's about IR0, IR1 and IR2. Now later we need to calculate IRY0, IRY1 and IRY2. But how to calculate IRY0, IRY1 and IRY2? Sir, to calculate IRY0, the only way is we need to know IRY, IYB and IBR. Without knowing IRY, IYB, IBR, it is not possible to calculate IRY0. We already discussed that. Let's see, the line value of zero sequence current is 0. But what about the phase value of zero sequence current? May exist. So there is no relation between IR0 and IRY0. So what my point is, IR0 and IRY0, no relation. Strictly speaking, this value is 0. There is no direct relation between these two. But there exists a relation between IR1, IRY1. There exists a relation between IR2 and IRY2. So the point is clear. If I know IR1, I can calculate IRY1. If I know IR2, I can calculate IRY2 directly. But if I know IR0, it is not possible to calculate IRY0 because there is no relation between these two. So that's why the point is, if you want to calculate IRY0, I need to know IRY, IYB, IBR. But what is the relation here? IR equal to, we can write IRY minus IBR. So that is equal to 50. IY equal to IYB minus IRY, that is equal to minus 20. IB equal to IBR minus IYB, that is equal to minus 30 amperes. But if you really notice, we have three unknowns. What are the three unknowns? IRY, IYB, IBR. But how many equations? Three equations. But strictly speaking, these are two independent equations. One is the dependent equation here. You can check that. So that's why using these three equations, it is impossible to calculate IRY, IYB, IBR. So if it is not possible to calculate IRY, IYB, IBR, it is not possible to calculate IRY0. So IRY0 is not possible to calculate here. So we can calculate IRY1, IRY2. Even we don't know IRY and IYB values. So how to calculate IRY1 and IRY2 without knowing IRY and IYB and IBR, using what? The relations. See, in case of delta, the line current equal to root 3 times the phase current at an angle minus 30 for positive sequence. For negative sequence, the line current equal to root 3 times the phase current at an angle plus 30 degrees. Clear? So line current we know, we need to calculate the phase current. So directly I am writing, sir, IRY1 we need to calculate. IRY1 is the phase current, that is equal to IR1 by root 3 at an angle plus 30 degrees. So IR1 is what? 25.166 at an angle 6.586 and 25.166 divided with root 3 at an angle 30 here and 6.586 here. So 36.586. So if I solve this, we get 14.53 at an angle 36.586 degrees. That's about IRY1. Now similarly, what is IRY2? IRY2 equal to IR2 by root 3 at an angle minus 30 degrees. So IR2 we know 25.166 at an angle minus 6.586. So 25.166 divided with root 3 at an angle minus 6.586 minus 30 degrees. If I solve this, we get 14.53 at an angle minus 36.586 degrees amperes. This is also in amperes. So we are calculated IR0, that is 0, IR1 25.166 at an angle 6.586 amperes, IR2 25.166 at an angle minus 6.586 ampere, but IRY0 is not possible to calculate. So this is the procedure for calculation of line currents and phase currents. That means sequence components of line current and sequence components of phase currents if the unbalanced line currents are given. Now we will go through the next example. Here the sequence components of line currents and sequence components of phase currents we need to calculate, but what is given in the problem is IRY, IYB, IBR. That means unbalanced phase currents are given. Unbalanced phase currents are given. We need to calculate the sequence components of phase currents and sequence components of line currents. So what are the sequence components of phase currents? Sequence phase currents IRY0, IRY1 and IRY2. Sequence line currents IR0, IR1 and IR2. So we can calculate first IRY0, IRY1 and IRY2 using IRY, IYB and IBR. So what is the relation? IRY, IRY0, IRY1, IRY2 equal to 1 by 3 times 1 1 1 1 alpha alpha square 1 alpha square alpha times IRY, IYB, IBR. Let's check what is IRY value. IRY value is 30 amperes now. Sorry, IRY value 20 amperes. This is 20 and 10 and this is 30. So let's calculate IRY0. IRY0 equal to 1 by 3 times 20 plus 10 plus 30. So which is 20 amperes. 60 by 3, 20 amperes. IRY0 is 20 amperes. IRY1, check IRY1 value. 1 by 3 times 20 plus 10 into alpha, 10 at an angle 120 degrees plus 30 into alpha square, that means 30 at an angle minus 120 degrees. If I solve this, we get 5.773 at an angle minus 90 degrees ampere. That's what IRY1 value. Now similarly IRY2 value. IRY2 is nothing but 1 by 3 20 plus 1 into 20 20 10 alpha square means 10 at an angle minus 120 degrees plus 30 alpha means 30 at an angle plus 120 degrees. If I solve this, we get 5.773 at an angle plus 90 degrees ampere. Now that's what IRY2. So IRY1 we got, IRY2 we got. Now what is IR0? Sir, IR0 blindly, which is equal to 0. If you have any doubt, what is the formula for IR0? IR0 equal to 1 by 3 times IR plus IY plus IB. That means these are unbalanced line currents and this is a sequence, zero sequence component of line current. So what is this IR, IY, IB? Sir, let's have a look. IRY value IRY value is what? 20. IYB value 10. IBR value 30. Now let's apply the KCL here. Incoming current is equal to outgoing current. Incoming is IR plus 30. Outgoing is IR by 20. So IR equal to 20 minus 30, which is minus 10. Now what is IB? Incoming currents here 10 and IB, outgoing current is 30. So IB is what? Plus 20 ampere. Now what about IY? Incoming current is here 20 and IY, outgoing current is 10 ampere. So IY equal to minus 10. Now just check. IR is minus 10, IY is also minus 10, IB is what? 20 amperes. If we add them, we get 0. So that's why IR naught value is what? 0. So what about IR1? IR1 we can calculate using what? The relation 1 by 3 times IR plus alpha IY plus alpha square IB. Since we are calculating IR, IY, IB, that is a one method. Another method is what? The line current equal to root 3 times phase current. What is the phase current here? IRY1. The line current equal to root 3 times the phase current at an angle minus 30 degrees using this relation. If I substitute IRY1, which is 5.773 at an angle minus 90 degrees here, what I get? 5.773 into root 3, that is 10 at an angle minus 30 minus 90, so minus 120 degrees. 10 at an angle minus 120 degrees is IR1. What about IR2? Root 3 times IRY2 at an angle plus 30 degrees. So using that relation, we get 10 at an angle plus 120 degrees. So these are the final answers. Now coming to this example, a balanced star connected load carrying an unbalanced current as shown below. So the unbalanced currents are what? IR, IY, IB. IR equal to 10 ampere, IY equal to 30 ampere, IB equal to 20 ampere given. Now it is a balanced load. Let's see here, the resistance here in R phase, Y phase, B phase are what? Same, and the neutral is grounded through a resistance of 1 ohm. Now he is asking to calculate sequence components of line currents. Calculate the sequence component of phase voltages and line voltages. First we need to calculate the sequence components of line currents. But one thing sir, sequence components of line currents and phase currents both are same. Why? It is a star connected load. For a star connection, line current equal to phase currents. Let's calculate IR0, IR1 and IR2. So in matrix form we can write 1 by 3 times 1 1 1 1 alpha alpha square 1 alpha square alpha times IR IY IB. Let's check what is IR value. IR value is 10 ampere, IY value is 30 ampere, IB value is 20 ampere. Now what is IR naught? 1 by 3 times, directly I am writing 10 plus 30 plus 20, which is 60 by 3, 20 amperes. Next, what is IR1? 1 by 3 times 10 plus 30 alpha, that means 30 at an angle 120 degrees plus 20 at an angle minus 120 degrees. If I solve this, we get 5.773 at an angle 150 degrees is IR1. Now calculate IR2. 1 by 3 times 10 plus 30 at an angle minus 120 plus 20 at an angle plus 120. If I solve this, we get 5.773 at an angle minus 150 degrees ampere. So we got IR0, IR1 and IR2. Now we need to calculate the sequence components of phase voltages and line voltages. For that, let's see sir, the current here is 10 ampere, means the voltage drop here is 10 volts. The voltage drop here 20 into 1, 20 volts. The voltage drop here 30 into 1, 30 volts. Okay, but what is the voltage drop in the neutral or neutral voltage? Actually neutral is floating because the neutral potential is not 0. And now neutral current is what here? IR plus IY plus IB, that means 60 ampere. Okay, so what is the voltage here now? So 60 volts, 60 into 1 ohm, 60 volts. So what you can understand from here is the R phase voltage, VR is what now? You need to measure with respect to ground. So let's apply the KVL in this loop. 10 and what? 60. 10 plus 60, 70 volts. And what about Vy? That means this is what our Y phase. Phase voltage I am writing. Vy with respect to what? Ground. You have to go like this in this loop. 30 plus 60, 90. Now what is Vb? Vb is what? The voltage from here to ground. So 20 plus 60, 80. So Vb equal to 80 volts. So we got Vr 70, Vy 90 and Vb 80. How to calculate the line voltages? Line voltages means Vry. Vry is what? Vr minus Vy. So what I get now? 70 minus 90, minus 20 volts. And what about Vyb? Vy minus Vb. Vy minus Vb. What is Vy minus Vb? 90 minus 80, which is 10 volts. And finally, the line voltage Vbr. Vry, Vyb, Vbr. Vbr means what? Vb minus Vr. Anyway, Vb is 80 volts. Vr is 70 volts. So 80 minus 70 again what? 10 volts. Clear? Now these are the unbalanced line voltages. Now these are the unbalanced phase voltages. Now we can calculate the sequence components of phase voltages and sequence components of line voltages. Let's see what is Vr0, Vr1, Vr2. 1 by 3 times 1, 1, 1, 1 alpha, alpha square, 1 alpha square alpha, Vr, Vy, Vb. These are the sequence components of phase voltages and these are the unbalanced phase voltages. We know what is Vr. Vr value 70, Vy value 90, Vb value is 80. So what is Vr0? That is a zero sequence components of phase voltage, which is 1 by 3 times 70 plus 90 plus 80. 70 plus 90 plus 80. So if I solve this, we get 80 ampere. So that means we get here 240 by 3. 240 by 3 is 80 amperes. Now what is Vr1? 1 by 3 times 70 plus 90 times the alpha, 90 at an angle 120 plus 80 times the alpha square, 80 at an angle minus 120. If I solve this, we get 5.773 at an angle 150 degrees volts. That is Vr1. Now what is Vr2? 1 by 3 times 70 plus 90 at an angle minus 120 plus 80 at an angle plus 120. If I solve this, we get 5.773 at an angle minus 150 degrees volts. That's about Vr0, Vr1, Vr2. Sir, what is Vr? Why not? The line value of zero sequence voltage, I don't need to calculate. Even if you want, you can calculate 1 by 3 times Vry, Vyb plus Vbr. 1 by 3 times Vry, Vyb plus Vbr is equal to 0. The line value of zero sequence voltage for star connection is always 0. So we proved that. Now what about Vry1? That means the line value of positive sequence voltage. I can calculate using the relation 1 by 3 times Vry plus alpha times Vyb plus alpha square times Vbr. That is the one method. Another method is directly using phase value of positive sequence voltage. So Vry1 equal to root 3 times Vr1 at an angle plus 30 degrees. So if I substitute here, what I get? 10 at an angle, root 3 into Vr1, 10 at an angle, 180 degrees we get. 150 plus 30 is 180. So what about VRY2? Root 3 into VR2 at an angle minus 30 degrees. So what I get now? Root 3 into 5.773 is 10 at an angle minus 30 minus 150 minus 180 degrees we get. So even you can calculate using the fundamental relations. So I am just writing one relation, VRY1. What is VRY1? 1 by 3 times VRY plus alpha times VYB plus alpha square times VBR. Let's substitute in this and calculate the value of VRY1. 100% you will get this. That is another method to solve. So I hope you are going to verify this. Calculate VRY1 using this and VRY2 using what formula? 1 by 3 times VRY, but here alpha square VYB, alpha VBR, and check the values of VRY1 and VRY2 and you should get this. Now we will solve another example. The positive and negative sequence phase voltages of a star connected load is 1 at an angle minus 30 degrees per unit, 0.8 at an angle minus 60 degrees per unit given. Calculate the positive and negative sequence components of line voltages. But careful, in this question is asking to calculate the line voltages, but what is given? The phase voltages. But what type of load? It's a star connected load. If it is a delta connected load, the answer is same. Why? Because for a delta connected load, the line voltage equal to what? Phase voltage. But it is a star connected load, so that's why, what is the relation, sir? The line voltage positive sequence equal to the phase voltage positive sequence, root 3 times the phase voltage positive sequence at an angle plus 30 degrees. But careful, this is the relation which is valid for absolute system. But what is given here? Per unit values are given. Check. Since the per unit values are given, that root 3 will not come. This is in per unit form. So what is given? V phase 1 at an angle minus 30 degrees plus 30 degrees. So 1 at an angle 0 degree is the positive sequence line voltage. What about the negative sequence line voltage? V phase 2 at an angle minus 30 degrees. Again I am saying, sir, here also root 3 will come? No, it will not come, because he has given in per unit phase voltage. So line voltage in per unit equal to phase voltage in per unit at an angle minus 30 degrees. So what I get here? V phase 2. What is V phase 2? 0.8 at an angle minus 60. Minus 60 minus 30. So 0.8 at an angle minus 90 degrees in per unit. So these are the final answers. Now coming to this example. In this example it is clearly mentioned that a single phase resistive load of 1000 ohms is connected between phases A and B of a 3-phase balanced 17.32 kV 58 supply. Considering phase A voltage is reference, calculate the sequence components of phase A currents. Considering phase A voltage as reference, calculate the sequence components of phase A currents. That means he is asking to calculate what is IA0, what is IA1 and what is IA2. But before that we need to know what is IA, IB, IC. Let's see what is mentioned. Let's say this is A, B and C phases. Where the load is connected? A single phase resistive load is connected between phases A and B. This is 1000 ohms. So you can calculate IA and IB. So IA equal to minus IB. What is IC? So this is B phase and this is C phase. Fine. What is IC? By default that is 0 because nothing is connected here. But it is clearly mentioned phase A voltage is reference. Okay. See what is phase A voltage here? Look. The phase A voltage. Actually the voltage given is here 17.32 kV. That is a line voltage. What is the phase voltage? VA. The phase voltage VA is 17.32 kV by root 3. Magnitude I am writing, sir. So that is 10 kV, but is clearly mentioned phase voltage is reference. VI is what now? 10 at an angle 0 degrees. So what is VB? 10 at an angle minus 120. What is VC? 10 at an angle plus 120. Clear? Otherwise, alpha square 10, 10 into alpha, right? But we need to know what is VAB, because the voltage across this resistance is VAB. Correct or not? It is connected between A and B. So what is VAB? VAB equal to VA minus VB, that is 10 at an angle 0, that means 10 minus 10 into alpha square. I told you this, you can also write 10 alpha square. So 1 minus alpha square times 10. If I calculate, this is root 3 into 10 at an angle plus 30 degrees. Otherwise simple. VAB leads VA by 30 degrees. VAB is the line voltage that leads the corresponding phase by 30 degrees. But line voltage magnitude equal to root 3 times the phase voltage. Okay. So that's about VAB. But careful, this is in kV. Don't forget that. Now, what is the current flowing here? The current flowing here is what now? The voltage divided with what? Resistance. That is what? IA. Correct or not? IB is minus IA. So that means IA, that is equal to voltage 10 root 3 at an angle plus 30 degrees divided with 1000 ohms into 10 power 3. Why? kV. So this get cancelled. So directly we can write 10 root 3 at an angle 30 degrees amperes. That is what IA. What about IB? Minus 10 root 3 at an angle 30 degrees. Because we know IB equal to what now? Minus IA. Next, what is IC? Nothing is connected between B and C. So IC is 0. So using this we can calculate what is IA0, IA1 and IA2. So the formula for IA0 is 1 by 3 times IA plus IB plus IC. So directly I am writing the formulas. I am not writing the matrix. Please notice that. IA plus IB 0, IC 0. So IA0 is anyway 0. What about IA1? IA1 is what? 1 by 3 times IA plus alpha times IB plus alpha square times IC. Anyway, IC is 0, IB equal to minus IA. So if I take that, 1 by 3 times IB is minus IA. IB is minus IA. So IA, if you take common, 1 minus alpha we get 1 minus alpha times IA. So what is 1 minus alpha? Root 3 at an angle minus 30 degrees. So root 3 at an angle minus 30 degrees by 3 into IA. So if I substitute IA value, IA is what? 10 root 3 at an angle 30. 10 root 3 into root 3 by 3, root 3 by 3, I am just multiplying, and minus 30 and plus 30. Minus 30 is there here, and what about this? Plus 30. So from this what I can write? IA1 equal to root 3 and 3 get cancelled. Finally it is 10 at an angle 0 degrees. IA1 is 10 at an angle 0 degrees. Now what is IA2? I am writing here. IA2 equal to 1 by 3 times IA plus alpha square IB plus alpha times IC. Anyway, IC is 0, IB is minus IA. So what I can write now? 1 by 3 times 1 minus alpha square times IA. So if I substitute 1 by 3, what is 1 minus alpha square? Root 3 at an angle plus 30. And what is IA? IA value 10 root 3 at an angle plus 30. 10 root 3 at an angle plus 30 is IA. So, if I solve this, we get root 3, 3 get cancelled, 10 at an angle 60 degrees. That is what? IA2. So, we got IA1 10 at an angle 0, IA2 10 at an angle 60 degrees. And what is IA0? IA0 value is what? 0. So, these are the final answers. Now, coming to this example, the symmetrical components of phase voltages of an unbalanced star connected load is VR0, VR1, VR2. The rated supply is 17.32 kV 50 Hz and is asking to calculate what is Vy in kV, what is Vbr in kV. By the way, he has given the rated supply is 17.32 kV at what? 50 Hz. Default it is line voltage or phase voltage? It is a line voltage. Indirectly this is the line voltage base. What about the phase voltage base? The phase voltage base equal to 17.32 by root 3 kV. So which is 10 kV. So the phase voltage base is 10 kV. That means you just multiply with this 10 kV. Why? By default VR0, VR1, VR2 are what? Phase value of sequence components, not the line values. So if I multiply with 10 kV, what I get here? The actual value. VR0 is 5 at an angle minus 120 degrees kV. Now similarly, if I multiply with 10 here also, I get 8 at an angle 30 degrees kV and 0.5 into again 10, so that is 5 at an angle minus 30 degrees kV. So we got VR0, VR1 and VR2, okay. But what is asking Vy and Vbr? Sir, we know the formula for Vy. Vy equal to what? Vy0 plus Vy1 plus Vy2. What is Vy0 equal to Vr0? What is Vy1? Alpha square times Vr1. What is Vy2? Alpha times Vr2. So if I substitute, VR0 is 5 at an angle minus 120 directly, plus alpha square means 1 at an angle minus 120 and here 8 at an angle 30. So magnitude is 8, phase angle is alpha square minus 120 plus 30, minus 120 plus 30 minus 90 degrees, plus alpha times VR2. Alpha is 1 at an angle plus 120, 120 minus 30, 120 minus 30 will be plus 90. If I solve this, we get 7.744 at an angle minus 108.83 degrees. But careful, this is in kV. That's about Vy. Now how to calculate Vbr? So what is Vbr? Vbr can be written as Vb minus Vr. Correct or not? It might be balanced or unbalanced, this relation is valid. Vb minus Vr. What is Vb? Vb0, Vb1 plus Vb2. What is Vr? Vr0, Vr1, Vr2. Clear? So Vb0, Vr0 are equal. Get cancelled. What I can write? Vb1 alpha times Vr1. Vb1 is alpha times Vr1. What is Vb2? Alpha square times Vr2. Okay? Vb2 is alpha square times Vr2. Vb1 is alpha times Vr1 minus simply Vr1, Vr2. So let's check here. Vr1, if I take common, we get alpha minus 1 times Vr1 Now if I take VR2 common, plus alpha square minus 1 times VR2. Now what is alpha minus 1? Alpha minus 1 is root 3 at an angle plus 150 degrees. And what is VR1? VR1 value is 8 at an angle 30 degrees plus alpha square minus 1. Alpha square minus 1 means this is root 3 at an angle minus 150 degrees, and VR2 is 0.5 at an angle minus 30. So 0.5 at an angle minus 30 means actual form 5 at an angle minus 30. So 5 at an angle minus 30 degrees. So what I get now? 8 root 3 at an angle 180 degrees, 150 30 plus root 3 into 5, 5 root 3 at an angle minus 180 degrees. If I solve this, we get minus 22.5166. That is nothing but 22.5166 at an angle 180 degrees. Now that's about VBR in kV. So we are calculated Vy in kV and VBR in kV. But one point I want to say here is, since VR0, VR1, VR2 given in per unit, here itself we are converted into actuals, so that later we don't have any confusion, sir, with the root 3 and root 3 multiplication and root 3 division. So VR0, VR1, VR2 are phase values. Directly I multiplied with phase voltage, so I landed with what? The actual values, so that you can comfortably apply the relations. But if you proceed everything in per unit, definitely you will get a confusion whether I have to finally multiply with line voltage base or phase voltage base. To avoid that confusion, so you must convert the values into actual by multiplying with what? Corresponding base voltage. For any given problem, you have to proceed like this. Let us solve another important model. A star delta transformer is shown below. The phase angle between VAB1 and capital VAB1 and small VAB1 is. See, the small letters indicates here what? The primary. Capital letters indicates what? The secondary. That is the first observation. Second observation is, this 1 indicates the positive sequence, 2 indicates the negative sequence. That means, what is asking here? What is the phase angle between the positive sequence voltage VAB in the secondary and the positive sequence voltage VAB in the primary? Clear? Similarly, in the second question, he is asking the phase angle between the negative sequence voltage VAB in the secondary and negative sequence voltage VAB in the primary. That means the phase angle between VAB2 and small VAB2, and phase angle between VA1 and small VA1 is asking. So how to approach this? Sir, to approach this, the first assumption here is, the windings which are drawn in parallel are on the same limb. That means they are in phase. Have a look here. This winding and this winding are in phase now. According to the diagram, this winding and this winding is in phase. They are drawn horizontally, correct or not? So that means this voltage and this voltage will be in phase. And similarly, let's see, this winding and this winding is what? Similarly drawn. That means this winding and this winding is in phase. That means these two windings are on the same limb. So the point is, the voltage here and voltage here is in phase. And similarly, this winding and this winding is what? Like drawn windings. That means these are in phase. Means these two windings are on the same limb. That means this voltage and this voltage is in phase. That is the first observation. Let us try to mark the voltages. But while marking the voltages, careful sir, always take the dot side is positive. Okay. Now let's see, what is this voltage here? Plus and minus. Shall I say this is VB? Correct or not? Phase voltage is VB for star correction. This is VB. Now tell me, what is this voltage? Star side is, dot side you have to take plus. plus minus, what is this voltage? VC. Now plus minus, what is this voltage? VA. Since you are taken dot side plus, here also you have to take dot side is plus and other side is minus. Dot side is plus, other side is minus. Dot side is plus, other side is minus. Tell me what is this voltage? VA, and this one is B. So VAB. But plus side is VB and minus side is C. So nothing wrong to say VBC. And here VCA. Now VA in phase with VBC. VA in phase with VBC, because these two windings are on the same limb. These two windings are drawn what? Same way. That means the like drawn winding, they are always in phase. So VA and VBC in phase, and similarly VB and VCA in phase. Similarly VC and VAB in phase. But first we will see for what? Positive sequence or negative sequence? We will go with the positive sequence. Positive sequence means this is VA1, positive sequence component of phase A voltage, here positive sequence. Now positive sequence means who will come next? B phase. This is VB1 and then what? VC1. Clear? Now after that check VA and VBC in phase now. So VA and this is what? VBC1. Now after that VB and VCA in phase. So here VCA1. Next after that VC and VAB in phase. So this is VAB1. Clear? Now what is the question? He is asking the relation between capital VAB1 and small VAB1. This is the capital VAB1. What is small VAB1? So this is VB1, right? Shall I write like this? What is this? Minus VB1, small VB1. If I add these two vectors, what I get? VAB1, small VAB1. Now just check, sir. From here to here 120 degrees, here to here 60 degrees. This is what? 30 and this is what? 60. That means what is the angle between VAB1 and capital VAB1 and small VAB1? 90 degrees. From this what you can understand? Capital VAB1 leads small VAB1 by 90 degrees. For this question, capital VAB1 is here, small VAB1 is here. Okay. In this direction, who is coming first? Capital VAB1. Next, small VAB1. So that's why what I can write, capital VAB1 leads small VAB1 by 90 degrees. Now we will write for negative sequence. So for a negative sequence, have a look, sir. This I can write VA2. Okay. Now what about this? After VA2, hello, what next? VC2 and then this is VB2. ACB, negative sequence, no? Right. VA in phase with what? Again, A and BC are in phase. So nothing wrong to write. This is VBC2. Then after that VC and VC, check this and this in phase. So VAB, here VAB, this is VAB2. Then after that VB means here VB in phase with what? VB in phase with VCA. So this is VCA2. Now what is asking? The relation between capital VAB2 and small VAB2. So what is small VAB2? So this is VB2. This length is what? Minus VB2. So if I add VA2 and minus VB2, the resultant vector is what? VAB2. Now this is our VAB2. Now check here, VAB2 and VAB2, small VAB2 and capital VAB2. What is this angle? Again 90 degrees. But what is the relation? Capital VAB2 lags small VAB2 by 90 degrees. Obviously, we already discussed. If positive sequence angle is plus 90 means negative sequence angle is what? Minus 90. Now, the third question. Third question is asking the relation between the phase voltage here and phase voltage here. But what is the value of VA1? That we need to evaluate first. The value of VA1 we need to evaluate, capital VA1. We know small VA1, okay. See, this is what the small VA1, but where is the capital VA1? That we need to identify. So for that we have a simple derivation here. We know that capital VAB equal to what? Capital VA minus capital VB. Na? So indirectly for a delta, you are measuring the voltage A with respect to what? Ground, with respect to zero potential. That is what VA. Correct or not? VA means you are measuring the voltage from this point to what? A ground. This point to what? A neutral point. Zero voltage reference. So that is nothing but VA. So VA minus VB is what? VAB. Fundamental relation. VAB equal to VA minus VB. Clear? Similarly, what is VBC? VB minus VC. What is VCA? VC minus VA. Now I want VA value here. So what I will write here is VAB minus VCA. So VAB minus VCA, that is equal to VA minus of minus VA, 2VA minus VB minus VC, minus if you take common we get VB plus what? VC. Sir, if the system is balanced, again I am saying, if the system is balanced, then only VB plus VC equal to minus VA. Tell me, I am talking about balanced system or unbalanced system here? 100% balanced. Why? Because with respect to positive sequence, system is always balanced. With respect to negative sequence, system is always balanced. That's why when you write VB1 plus VC1, nothing wrong to say minus VA1. When you write VB2 plus VC2, nothing wrong to say it is what? Minus VA2. Because by default positive sequence is a balanced system, negative sequence is a balanced system. Original system may be unbalanced, but positive sequence alone is balanced, negative sequence alone is balanced. So that's why the point is here, I can write VB plus VC equal to minus VA. So that means minus VA into minus plus VA plus 2VA. Total is what? 3VA. So VA equal to VAB minus VCA by 3. Clear? Suppose you want VA1, then VAB1, VCA1. That's it. If I want VA1, VAB1 minus VCA1 by 3. So using this relation, we can understand what is the phase angle between capital VA1 and small VA1. Let me draw the phasor diagram once again. So first I will show here VA1. This is what our VA1, which is reference. Then after that VB1, then VC1. Okay. VA1, VBC1 are in phase. So this is VBC1. Clear? Then VB1 and VB1 and VCA1 are in phase. Next, VC1 and VAB1 are in phase. Now we want VAB1 minus VCA1. This is VCA1, okay, but minus. Now if I add these two, the resultant is what? 3 times the VA1. Check sir, VAB1 minus VCA1 is what? 3 times the VA1. That means VA1 vector is here. Okay, exact value of VA is what? Here. This is what VA1. Because if this is 3 VA1 means what? This length is. This small length is what? VA1. Okay, anyway, this is a VA1 vector position and this is small VA1. From this what you can understand? Capital VA1 leads the small VA1 by 90 degrees. Capital VA1 leads small VA1 by 90 degrees. Clear? And similarly, what about capital VA2? Capital VA2 lags small VA2 by 90 degrees. Simple common sense, sir. I don't need to solve for that. I can apply the common sense. What is the common sense here? If the relation is that positive sequence leading means negative sequence must be lagging. That's it. The blind way you can remember. So, for solving any kind of problem which is with respect to transformer phase shift, you have to observe one thing, sir. The like drawn windings, voltages always in phase. So these two windings are drawn in a same manner. These two windings are in phase. These two windings are in phase. These two windings are in phase. That is the first observation. Second observation is dot side you better to take positive. Even you take negative also, nothing wrong. But better to take dot side positive here. Here also dot side positive. If I take negative here, here also you have to take negative. Then you can draw the phasor diagram. That's enough. You will get the answer for the relation between positive sequence line voltage in the primary, positive sequence line voltage in the secondary, positive sequence phase voltage in the primary, positive sequence phase voltage in the secondary. And similarly, you can get for what? Negative sequence voltages as well. With this, I am concluding this lecture. In the next lecture, we will see the sequence networks.